Quadratic Formula Arithmetic today. We're in Module 2 of College Algebra. And so Q&A, we'll take any question that you have. And we'll get to the ALA, Quadratic Formula Arithmetic, which is not easy. So, Gabriella, do you have any question today? About homework, about the course, anything at all? Any question? Anyone? All right, well, we'll go to the ALA then. There's no question. Teamwork and tutoring. So I guess we're done with tutoring. We'll go into the teamwork. We're going to go to the ALA, and so remember how to get there. You are on the MOM homepage, where everything, the matrix, that is MOM, the matrix from which everything comes. Did you know that the word matrix has the same root as the word mother, I guess? Same etymology anyway. But module 2 tells you there's an ALA in here. And I think it's this one. It doesn't have the name of it in there. And so if you're in this meeting, what you will do is follow this link right here to get to the ALA. And so that we can all be in the same, work on the same slides, where we all have to have the same name, and that name is 22222. 5 2s, and that will put you here. And of course, what you'll do at this point is in some white space up here somewhere, you will write your name and the color that you're going to be using for this activity. And we have a focus question here. And so I'm going to let you kind of struggle with it. A focus question often involves struggle because people have to stop and think and maybe consult a source. And it's not just like you see some symbols and then you're like, oh, okay, do some math. Your hand starts moving and you're not even really thinking about what you've been asked to do. A focus question is different than that, but it's something that's really important in, learning how to do math. All the terms are important. And do you go by Gabby? I think I saw somewhere where you said you go by Gabby. which is what most people, there you go, what most people named Gabriella do. Okay, so yeah, focus questions, really important, huge contribution. Um, so talk to each other. Like, what does this mean? And it's like the one of the best contributions you can make to our little community here as we try to do this assignment together. And so I'm going to try to be quiet. Sometimes I can't do that. I try to measure the amount of, what's the amount of learning that's going to happen if I talk, and what's the amount of learning that's going to happen if I don't talk? Because I totally believe in learn by doing. But I'll shut up and let you read this and think about this focus question, and hopefully talk to each other and come up with an answer. Okay, I don't think that that's right. Um, for any interpretation, for any use, or for any when is it true that? I mean, okay, so now if we replace the a that you had there with an x, now we're getting closer to something that could be what we want. It's not exactly right though. I don't think. I don't think that that expression right there is helpful for any case. That expression as written, I don't think is quite right. We can work with that. This is the answer that I know I would get if I just left it at write the quadratic formula. If I just said that, 99% of the time, I'm just going to get this, what's here. And so I'm trying to make this equation here meaningful. So I'm saying, say what it does. If you just have A's, B's, and C's, which is pretty much what we just have here, it doesn't get the job done. In other words, when? When is it true that x equals minus b plus or minus square root b squared minus 4ac all over 2a? I mean, those symbols have to mean something. It has to be in a context of some kind for those symbols to mean something. And so I've tried to restate this a lot of different ways. But yesterday I saw uh, a tweet that expresses what I'm trying to say here. Okay. And it's not with the quadratic formula, it's with the Pythagorean theorem. But I mean, it's like the same thing, right? A's, B's, and C's, and it's like a familiar formula, but like when is it true? See, we're missing we're missing this part. All we get is the equation, right? But we're missing like when is it true? what does has to be true about A, B, and C for this equation to hold? Okay. Does this expression, is that meaningful if A, B, and C are the lengths of sides of a right triangle? No, it's not, that wouldn't even be true in that case. So what's like the rest of it? And maybe you have to consult a source for that, which is fine. One source could be a textbook. Okay, so here's the OpenStax app that last I checked could not be found in the Apple App Store. But of course, there are many versions of our textbook. And it's a shame because this app is really nice. But, well, let's see. The calendar says that we're in section 2.5 right now. So maybe what we need to write the quadratic formula completely is in section 2.5 of the textbook in whatever version, online, the PDF, Kindle, lots of different versions. Oh, okay. Oh, yes, Brianna. So the class code you don't even need, right? What you do is you um, follow the link here in Mom. So here's Mom. Okay. And by the way, um, the textbook, I said, there are different versions of it, but they're all like right here, right? Textbook info. Let's see. Textbook. Oh, how about opening the block? Yeah, there are all the versions of the textbook. And I'm just guessing that 2.5 might be a good place. But anyway, Brianna, um, yeah, in Mom, you follow this link right here, and then you don't have to worry about the code. You just put in the password, which is 22222. So you follow it. Your name, your not password, your name is 22222. Now put you in the same place where we are. Trying to wrap our minds around this quadratic formula thing. Well, the objectives for section 2.5 are solve quadratic equations this way, solve quadratic equations the other way, solve quadratic equations still another way. And the last objective is solve quadratic equations by using the quadratic formula. So one would guess that a full statement of the quadratic formula is right here in section 2.5. And there it is. And as you can see, if I've given you a good look at it, there are words there. So we need the words here too. We want to break out of this caricature of students that this snarky professor tweeted and state the full quadratic formula. Are you finding us, Brianna?
I think I did something wrong.
Okay. Did you get a screen that looks like this?
Yeah.
And did you put 22222 in for your name?
No. I think that was why. Okay. Okay, I'm here now.
Great. How are we doing with consulting a source on this? You probably know it, but you don't realize you know it. But did we find this in the textbook or just do an internet search on quadratic formula? let me ask this. Do we all have a a go-to way to access the textbook? Okay, textbook, course introduction information. There's our textbook. Do we all have a go-to way to access the textbook? Because, I mean, that's like part of a course, right? So, Sarah, do you have a go-to way to access the textbook?
I use the links on the homework. I found the 2.5. I've been reading over it, just trying to understand the purpose of the formula a little bit more.
Okay, sure. And, you know, if you just find the box, usually there's a box, there is in the app, there's a box that states, and it's with a big title, the quadratic formula. And if you just write word for word what it says there, that's good. I mean, that's what we need. Really, it's not, you're going to impress me by, you know, putting it in your own words. We need to, you know, understand the words, the language of math. And in order to understand these things and wrap our minds around them, you know, it takes like right looking at it word for word as it's stated, memorizing things. So nothing wrong with writing it word for word. I suggest the text tool for that, right? Gabby used the pen tool. All of you use the text tool to write your names, so probably would be the thing. And to use to write, you know, to indicate that you are writing an exponent, you can use the caret. You could even copy and paste. You could even get a screenshot of that and paste it. That's not really usually the way we want to do it, but or maybe just the part that's not written that Gabby didn't write. Brianna, do you have a go-to way to access the textbook?
Yeah.
Do you do the online version or what?
I do the online version.
Hmm. Okay, so that's part of it. So piece by piece, we'll get this. Very important to get to know our definitions and formulas and key equations. Okay, now we have to specify the meaning of A, B, and C, right? Because what do A, B, and C mean in order for this to be true? Are A, B, and C the lengths of sides of a right triangle? Well, no, then we would need a different equation. So what's the meaning of the A, the B, and the C? I mean, we're getting close. Gabby, I thought you were gonna, I was hoping that you were gonna write something that had the A, the B, and the C and kind of explain what they meant there. And you got close to it, but it's not really it. This is what Sarah wrote. That's good. I mean, that's good to have in there. It doesn't really explain why. It says what they are, real numbers. Okay, that's good. That helps. But what else? What's the crucial thing that's true about A, B, and C? Sarah, it looks like you took the kind of the fine print of the statement of the quadratic formula in our textbook in section 2.5. But then there's another part that's the missing part that I'm talking about. Yeah, and then you can just maybe put an arrow to the blue equation. Good, perfect. Um, whoever wrote that, that's yes, exactly. Good, fantastic. So it's only when ax squared plus bx plus c equals 0 that x equals minus b, etc. That's when you're given a quadratic equation, that's when this is true. All right, thank you. No, you can't cancel like that because of the plus sign. If it were multiplication, then you could do that hack, but it's in addition, so you can't, you're not allowed to cancel like that. Okay. The answer's right. Um, one way to do the work on that is to write, okay, let's split it apart. 2 over 2 plus 2x over 2. And then now just within this little box here, you can cancel, cancel. And now you have 1 plus x. Okay, good. So yeah, and of course, you don't want to make that x look like it's in the denominator. It kind of looks like it's the exponent on 3. Okay, perfect. And this kind of simplifying is part of the whole process of doing quadratic formula arithmetic. So Gabby, what you could do is just start on slide 3. 'Cause it looks like Sarah's doing this problem on slide 2. Brianna, what do you think about how this is going on slide 2? Do you have maybe a suggestion for Sarah?
Um, not really. I was trying to do the stuff on slide 3.
Okay, okay,
I was working on it.
okay,
Do
sure.
the second one.
Yeah, you can just keep doing that.
Okay.
Okay, Sarah, a radical symbol, you got to be really careful about how you work inside and outside of it. For now, it really needs to be the radical symbol still needs to be over all that, the 100 and the 96 as one radical. And what you want to do is extend this radical symbol, just keep it the way it was over here. So yeah, Sarah, on that one, you can keep simplifying this thing and get, I mean, that's correct right there. And you could just keep simplifying it to something even nicer. Now, Gabby, I like that answer over here on the left, but mom doesn't like it. We got to please mom. So what we're going to want to do is simplify this radical and then do more simplifying after that. And Brianna, that's negative 27 under the radical.
Oh my God. I got 27, but I accidentally put 37.
And Sarah, you can simplify even more and write your answer as two nice little positive integers. They say separate each pair of answers with commas, um, which is something that mom often says too. Okay, so simplifying the radical, that's a thing that you may or may not have been taught in your high school math class. Um, Gabby, do you know how to simplify the square root of 40? Brianna, do you um, know where to go from here with your expression?
No, not really.
Okay, well, the first thing we want to do is, we have to deal with that negative under a radical. And so there is kind of a property of complex numbers. And it's like a rule that you memorize that everyone really needs to memorize or know that for n positive, if you have the square root of negative n, that's I times the square root of n. Of course, you can switch the two factors. And so square root of negative 27 is square root of 27i with I on the outside. Okay. And then the issue is, okay, simplifying the square root of 27. So you're now that'll put you, maybe you know how to do that, but that'll put you in the same place where Gabby is here. Looks like she's got it. Yeah. Yes, yes, that's right. Okay, Sarah. Um, the answer is correct, and I mean, this is okay, but we wouldn't want someone to think that this expression here is true. That's not the same as any of these things, because of course this right here is 14, because 14 times 14 are 196. So actually, all this would be perfect if we if we just had a 14 right here. And Gabby, mom would want you to simplify, um, reduce these fractions basically. Now, simplifying the square root of 27. When we're simplifying a radical, okay, so Gabby did it all like in one step. She saw that 40, she realized there's a perfect square factor of 4 in the 40. And so what we have to do when we're simplifying radicals is look for a perfect square factor in the radicand. The radicand is the thing under the radical. So perfect square, perfect squares are 4. That's the one that Gabby recognized. 9 is the next one. 7 squared, 8 squared, 9 squared. Okay. So in this radical, Brianna, we're seeing this 9 in there, aren't we? Right? It's 9 times 3. So isn't it this, Brianna? 3 plus or minus square root 9 times 3 under the radical, and then that I outside the radical, all over 2.
Yes.
Okay. Now, Gabby had a square root of 40, which is the square root of 4 times 10. And then she was able to write that as 2 times the square root of 10. And so you'll do something similar with the square root of 9 times 3. The in-between step there for Gabby was square root of 4 times the square root of 10. Okay, so what so far, maybe I'm just stepping on your work here, but Brianna, what you've just written is the same thing as all this down here. Maybe you have to scroll down to see what I'm showing, but the 9 isn't there and the I isn't there. They just kind of disappeared. Um, so how do we account for the 9 and the I? The way we do it is um, 3 plus or minus, break this up, square root of 9, square root of 3. The I is still there, all over 2. Which is 3 plus or minus. Okay, that square root of 9 there, that's just 3, right, Brianna?
Yes.
And then we still have the square root of 3 there, and we still have the I, and we still have the 2 down there. And that's the answer, not written as separate the answers with commas, we didn't do that much, which mom often likes, and I think is like part of the instructions here. But that's like the answer. $72. So 4 is a perfect square factor of 88, right, Sarah? Okay, multiplying top and bottom by 2 doesn't really help, but it looks like maybe you're going to end up in the right place. Okay, so Sarah, at this point, what it is, well, let's just back up and say, okay, under the radical, what you have Okay, we dealt with the negative under the radical. So 0 plus or minus square root, and under the radical, we have 4 times 22. Okay, so that's what it is at this point. And of course, you don't need the 0 because 0 doesn't add anything or take anything away from the rest of it. So how do we break down 4 square root, 4 times 24, 22, I on the outside, all over 4. And it's plus or minus. Don't want to forget that. Oh, that was good, Gabby. Yep, perfect. Now, let's go ahead and do the step where we separate with commas the two answers. And it's okay to change colors, to write on the blue if that's what, you want to do. So we want to write the two answers, right, Gabby, separated by a comma, because that's what we have here, two different numbers, one with the plus and one with the minus. Yeah, like a light color like white or yellow. Um, but I can see what you're writing. Now, the answer with the plus is 2/3 plus I times the square root of 14 over 3. That's the answer for the plus. And then there's another answer for the minus. Whoa, where'd all that stuff go? Did I do that? Did I get rid of all that stuff? Okay, so anyway, um, I guess I did that. I can't believe I did that. But I think we got out of that what we were trying to get. Of course, I think, Sarah, you got the plus or minus 1/2 times the square root of 22i for the two answers. And then we want to write the two different answers. We're trying to separate it with a comma Okay, so yeah, there you go. Perfect. So maybe we can get someone to do number 4 there on slide 5, and then I'll do number 5 because of time. It's a nasty problem. Anyone for number 4? Okay, so this is probably correct if you mean minus, not equals, right? Um,
Yes.
okay, but the important, the most important thing that I would like to see here is the first step done. Isolate the radical expression. Now on this one, what that would mean is subtract 7 from both sides so that we get square root x minus 1 equals x minus 7. And then the way Brianna gets what she got is we, square both sides. And then the squaring undoes the square rooting. So we cancel, cancel, cancel. And then x minus 7 times itself turns out to be all this. And then we go from there. Okay. Now I'm just going to do number 5 and we'll call it a day. So this is nasty because you have the radical on both sides. So how do you even do this thing where it says isolate the radical? You can't do it completely. The best you can do is to isolate the radicals from each other. Treat them as fighting children. And separate them from each other. Subtract square root x plus 7 from both sides. And that'll give us square root x minus 5 equals 6 minus the square root x plus 7. Then we do the square both sides step, because squaring undoes square rooting, right? They undo each other. So this is algebra. We undo, whatever's been done. So we square both sides. On the left side, we've got that nice cancellation. So it's x minus 5. On the right side, we've got nastiness, okay? Now, what people want to do is apply that to both things. But it's not the distributive property. You can't do that. What we're doing is squaring something, so we have to write it as the base as multiplied by itself. So 6 minus square root x plus 7, and then another one of all that. 6 minus square root x plus 7. And then we have to deal with that craziness. Okay, so, hey. Okay. So dealing with all the crazy, x minus 5 equals, and we have to FOIL. So 36. Then there's this product, so minus 6 times the quantity x plus 7. The product of the insides is also minus 6 times the quantity x plus 7, or times the square root of x plus 7. Same thing again. And then kind of the easier part is this product here, which is the square of the square root of x plus 7, which is just x plus 7. We're going to combine these two things now. So x minus 5 equals 36. Negative 6 of them minus 6 of them are a negative 12 of them. Plus x plus 7. I think a different color here would be better. Okay, so a lot of stuff going on there, but we can make it nicer if we just subtract x from both sides. That leaves a negative 5. The negative sticks on the 5, right? Negative 5 equals 36 minus 12 times the square root x plus 7 plus 7. Negative 5 equals 36 plus 7, 43, minus 12 times the square root x plus 7 we're trying to isolate the radical. That's what kind of, you know, redoing step one, because we have to isolate the radical. We have to do that like every time. If you have two radicals in the equation, you have to do it 2 times. Subtract 43, trying to get that radical by itself. Subtract 43, negative 48 equals negative 12 times the square root of x plus 7. Still working on getting that radical by itself. We're going to get rid of the multiplier. So divide both sides by negative 12. Negative 48 divided by negative 12 are 4. And now we can cancel the negative 12s. Square root of x plus 7. Square both sides. Squaring undoes the square rooting. 16 equals x plus 7. Subtract 7 from both sides. And we're getting 9 as what x is. Now, we always have to check our solutions to radical equations, because funny things happen. We get fake solutions in radical equations. So we always have to check it. And we're going to check 9 in the original. So to do that, we would put 9 in there for x and 9 in there for x. And it's going to be, let's see, 9 minus 5, that's 4, the square root of which is 2. 9 plus 7 are 16, the square root of which are 4. And so 9, we are getting the truth here, and we are getting actually a good solution of x equals 9 for this problem. All right, gotta get it done for today. Great effort today, everyone. I really appreciate how you were willing to endure that pain of the focus question. I think that is going to do you good. Pain is good. So anyway, have a great rest of the night.